Hello, beautiful people. Welcome to 6-3 solving systems using elimination. This is our third and final method for solving systems. So, and that's what our swab at is to be able to do this by the end of this lesson. So number one, broke this down into steps again. Multiply one or both of the equations by a constant to get opposite coefficients for one of the variables. Opposite coefficients would be like if I have 5x, I want negative 5x. If I have 3y, I want negative 3y. Same number, but opposite signs. Same variable too. If I have 17x, I want negative 17x. Part 2, add the equations to eliminate one of the variables. Number 3, solve for the remaining variable. And number 4, substitute it into either of the original equations, because we're going to do some funky things with these, and usually the original one's going to be the most easy to work with. So let's begin. We'll go through these steps kind of together so we can see how they work. And so I'm looking at these, and I can choose whichever one I want. I can choose to get rid of the x's or the y's. My direction solved by elimination. I can get rid of the x's or the y's. So do I have a preference? I don't. Let's just get rid of the x's because both of them seem pretty user-friendly. And to do that, what I'm thinking of is what's the number that 2 and 4 can go into, the least common multiple. If you're thinking about everyone's favorite F word, fractions, what would these both have as the least common denominator? Well, it would be 4. Same concept here because they can both go into 4. That's the smallest number that they can both go into. So I have to multiply this top one by 2, but if you go back here, it says that I want to get opposite coefficients. Well, this is going to give me 4x and 4x. That's not what I want. If this is 4x, I need the other one to be negative 4x. So I'm going to multiply that one by negative instead. So let's multiply. Let's see what we get. Let's distribute. We have negative 4x minus 2y equals, and negative times a negative makes that positive 18. And then the bottom equation was fine just the way that it was. So I'm going to rewrite it. 4x plus 11y equals 9. I just multiplied to get opposite coefficients, and now I have them. So step 1 is kind of done. Step 2, I'm going to add these two straight down. And negative 4x plus 4x, nothing. They cancel each other out. That's great because that's what I wanted to do. I wanted to eliminate one of the variables, and I just did. Negative 2y plus 11y is 9y equals 18 plus 9 is 27. Then what times y gives me that? Should be y equals 3. I just did that. I just solved for the remaining variable. And now, last step, substitute that into one of the original equations. I'm going to choose, you can pick either one you want. I'm choosing the top one only because it looks easiest to me. It looks like the numbers are smaller, so to me that's an easier choice. Now instead of y, I'm putting 3. And then to solve, I'm going to subtract 3 on both sides. And I have 2y equals negative 12 divided by 2, y equals negative 6. I'm just kidding. Did I switch the variable? Yeah, I did. This was an x. Sorry, guys. Love me, love me, love me still. This was an x, and this was an x. I don't know. I'm attached to my x still. Ha ha. So I have negative 6, and just don't tell my husband. No, I'm kidding. I'm not attached to any x's. It's crazy. X is negative 6. Y is 3. So as a coordinate, negative 6 and 3. All right, let's try another one just like the other one. 2x minus 3y equals 6. 7x plus 4y equals negative 8. Again, you can pick either variable you want to. This time, my eye is going to the y's. Do you know why my eye is going to the y's? Because it already has one positive, one negative, which is great. So now I'm thinking, okay, what's the smallest number that 3 and 4 can go into? 3 and 4 can both go into 12. So that's the number I'm going to try to get them both to. So I'm going for the y's. I have negative 3 right now, so I'm going to multiply by 4. And I'm going to distribute 4 times 2x is 8x. 4 times negative 3y minus 12y equals 24. And then what do I have to multiply 4 by to get to that 12? 3. So I get 21x, that's a big number, but we're not freaking out. 3 times 4 plus 12y equals 3 times negative 8, negative 24. Cool. Negative and positive 12y cancels out. 8x plus 21x is 29x equals, what's 24 minus 24? 0. What times 0 gives me 0? 0. So x equals 0. Beautiful. Now I'm going to plug that x into either one of the original equations. I can use this one or this one. Does not matter. These just look smaller because it's a 2, 3, and a 6. So I'm going to go for that one. Either way, you're going to get the same answer. So this is what I'm going for. And instead of x, I'm going to put 0. So this is 0 minus 3y equals 6. Divide by negative 3. Y equals negative 2. Because 2 times 0 was 0. That's why I got rid of that. I don't want to write 0 minus 3y. So what's my point? Well, remember they go x and then y. So I have 0, negative 2. Beautiful. All right, let's do this. Actually, let's not. How about you decide which method you want to use, and then use that method to solve part C. Try it without me. First decide, do you want to get rid of the x's or the y's? All right, go ahead. Press pause if you need to, so you can check your work with my work if you need to. You did x's and the y's. If you got this answer, 9, negative 3, as your coordinate, then you're all good. If not, I want you to go back, because I did this 2 different ways to make sure that you're okay. If you eliminated the x's, you had to multiply the top one by 3, and then the bottom one either by, top one by 3, bottom one by negative 2, or negative 3 and positive 2. One of the things has to be negative in order to get these to cancel out, because right now they're both positive for the x's. So, but check your work, make sure, because you should get the same answer. So just double check your work with mine. You can press pause if you need to. If you did the y's, which is actually a little bit easier, all you have to do is multiply top one by negative 2, and then you get your negative 10y and positive 10y, and they cancel out. So you get the same coordinate. Either way though, guys, look, same answer. You're going to get the same answer if you decide to multiply this by positive 2 and negative 1. It's just a lot more work, but look how easy that one is. And then 3 and 2 are great numbers. The only thing is, make sure that you multiplied one by a positive and one by a negative, and then you're okay. Again, go ahead and press pause right now if you need to, in order to check your work, or if you just need to glance at my beautiful writing for just a little bit longer. All right. Beautiful. Now, let's do some problems with words in them. Let's talk about my homie Jack. Jack bought a total of 20 pounds of grass seed at the nursery for $168. He paid $9 per pound of Kentucky bluegrass and $6 per pound of tall fescue. Write and solve a system of equations to find the amount x in pounds. So that's great. It's kind of a gift. They are giving me my variables. They're telling me x is for the pounds of bluegrass and y is the pounds of tall fescue that Jack purchased. Total seems important to me. So he bought a total of 20 pounds of grass seed, and he spent a total of $168, and he paid $9 per pound of Kentucky bluegrass and $6 per pound of tall fescue. If you could, go ahead and press pause and write your 2 equations right now. Given that he did x plus y, the total amount of pounds will be 20, and then he spent money. He spent 9 for every pound of x plus 6 for every pound of y to get $168. Now, press pause. I want you to start practicing this on your own. You can get rid of the x's or the y's. I'm probably going to go for the y's. So what does 1 and 6 go into? I can multiply this by 6, but in order to get opposite coefficients, I'm going to go for negative 6. Then I'll distribute. Negative 120. This equation stays the same. That's a 6 equals 168. So this will give me 3x is equal to 16. So this bothers me. Like, I can't see it in my head. I always need to write the bigger number on top. And now I can see, okay, that's 8, and that's 4. Okay, it's 48, and that makes me happier. Then I'll divide by 3, and I get x equals 16. So I am seeing that he bought 16 pounds of X. Well, what was X? Kentucky bluegrass. So 16 pounds of Kentucky bluegrass. And I say Kentucky bluegrass. And, well, beautiful people, if he bought a total of 20 pounds and 16 of it was Kentucky bluegrass, how many left to be the other one? 4. 4 pounds. And what was the other one? Of tall fescue. These are like legit types of grass. I just have never used them or heard of them before. Okay, we're going to do the setup for this one together, and I want you to solve it on your own. A sports equipment store is having a sale on soccer equipment. Delightful. It's just what I needed. A soccer coach purchased 10 soccer balls and 2 soccer ball bags. They're probably those little mesh ones, for a total of $155. Another coach, so Coach B, what did he get? Or she get? Let's say she. She bought 12 soccer balls and 3 soccer ball bags for a total of $189. She probably had a little bit more needs then. Find the cost of a soccer ball. So here's my question. The cost of a soccer ball, I don't know what that is, so I'm going to make that X. Since they didn't define it for me. And they want me to also find the cost of a soccer ball bag. Cost of soccer ball bag. Cool. All right. Let's look at this one. It's a little bit different. We got this, though. We got this. So, what's my first coach? I think I did that one in this pinkish color. 10 soccer balls and 2 soccer ball bags for $155. So she spent a total of $155. So there's 10 soccer balls for how much? If the soccer ball was $10 and she bought one of them, she spent $10. If she bought 2 of them, it would cost $20. Let's chart that. One would be $10 because she I'm sorry guys, because they're 10. If she bought 2, they'd be $20. If she bought 3, they'd be $30. But she didn't. She bought 10. So it's 10 times however much they are. I made up that $10. I don't know how much they are. They could be 20, they could be 3, they could be 7. I've never played soccer. I don't know how much a soccer ball is. But I know that these ones at this store for this sale, they cost X dollars. X dollars. Plus, she also bought some soccer ball bags. She bought 2 of them. 2 of them for every one that she bought cost, I don't know, Y dollars. We don't know how much that one costs. It's 2Y. If you see that, go ahead, please press pause. I welcome you. I invite you. And then set it up for the other coach. I do not know why this equal sign is so far. Oh, because I started off with what it was. The total was 189 for this one and 155 for that one. Okay, we can use elimination, and you have options. I'm going to give you a hint. I really believe that we can get rid of the x's or the y's. The x's is a little bit more complicated to me because the numbers are big. Therefore, I am going to choose, make an executive decision, to multiply this by -3. And this by 2, because 2 and 3 both go into 6. I got to multiply this one. One of these has to be multiplied by a negative. Doesn't matter which one. So I get -30x minus 6y equals, I don't know what that is in my head, but I will find out. I get -465. Then I multiply everything on this one by 2. So I get 24x plus 6y equals 2 times 189 is 378. I have my opposite coefficients. Delightful. V's go away. Negative 30 plus 24 is negative 6x equals negative 87. Now to solve for x, I'm going to divide by negative 6, and I get x is equal to 14.5. Is that scary? Not really. It just seems a little bit more real world. So that means the cost of a soccer ball is $14.50. Now, how about the other one, the bags? Which one looks easier? I think I'm going to go with this top equation. 1, because that 10 looks nice and user-friendly. 2, because the numbers are just a little bit smaller. So to multiply by 10, I can move it over once. 145 plus 2y equals 155. Minus 145 minus 145. 2y equals 10. Ooh, almost got me there. And so y equals 5. So the cost of a soccer ball bag is $5. There we go. All right, beautiful people, thank you so very much for joining me, and have a wonderfully blessed day. See you soon.